Hello and welcome back. So in our previous videos we discussed about how to deal with second order equations of constant coefficients, how to find out the general solution. First we find out the complementary solution, we find out the particular solution, and sum of these two is going to be our general solution. Okay. So that was just in case of linear equations with constant coefficient. Now we are going to talk about reduction of order. There are some particular cases in which we can simply find out the general solution. Doesn't matter if our equation is linear or non-linear, if the coefficients are constant or not. So if we have a equation of, if we have a second order equation, it will be some function of x, y, y prime and y double prime equal to 0. Our equation will look like this. Okay. Now there are two cases when this equation can be solved very easily, and we are going to discuss those two cases in this video. Okay. The first case is if the dependent variable y is missing. Dependent variable, say y, is missing. So in that case our f will involve x, y prime and y double prime. Our equation will look like this, right? So what we are going to do is we will substitute p equal to y prime. This p is a function of x. Y is missing here. This p is a function of x. Okay. So if we substitute p equal to y prime, then y double prime, which is the derivative of y prime, is derivative of p, right? So our y double prime is dp over dx. Then our equation will be in terms of x, p and the first derivative of p. So instead of second order, we reduced our original equation into first order, and we know how to deal with the first order equation. We already learned that. The second case is when independent variable is missing. Here we chose our independent variable as x. If independent variable is missing, in that case our equation will be of form f, y, y prime, y double prime equal to 0, right? Here also we will substitute p equal to y prime, but this time p is a function of y. So y double prime will be equal to the derivative of p, right? Okay. So x is missing. We want to replace the derivative of x with respect to something. We don't want to involve x at all. To change this into first order ODE. So this by chain rule can be written as, by chain rule this can be written as the derivative with respect to y times the derivative of y with respect to x, since p is a function of y. Now dp over dx, this we defined as p, so our y double prime is p times dp over dy. So our equation now is in terms of y, p and p times dp over dy. 0. So in this case we will treat our y as the independent variable, and we will solve this first order ODE for p, and then with respect to that p we will calculate our y. Okay, so let's write down two important notes. In this case our p is a function of x. Here our p is a function of y. So when x is missing, p is a function of y. Okay, two simple cases, and you will see that this method is actually very simple, very easy to apply. You don't need to remember actually anything. Okay, let's see example. So our first example is solve the equation x y double prime equal to y prime. Okay. So first observation, this is second order ODE and there is no y term. The y variable is missing here. So we will substitute p equal to y prime. So what is our y double prime then? The derivative of p, right? Let's replace this information in our equation. So x times y double prime equal to y prime, which is p. This looks pretty simple. If you observe, this is basically a separable equation. So p times dp is equal to 1 over p. We divide by p both sides. So we will get 1 over p dp is equal to 1 over x dx. Derivative of p is ln p, derivative of x is ln x, plus we add a constant of integration, say c1. Okay, so p, if we take the exponential function both sides, we will get p equal to e power ln x times e power ln c1. So p is equal to c1x. We got the value of p. But we wanted to find out our y, right? So p is equal to y prime. So y prime, we integrate both sides with respect to x. The derivative and the integral are opposite of each other. So on the left hand side we get y equal to integration of c1x dx, c1 x square by 2 plus c2. c1 over 2 is going to be a new constant. We can give it a new name just for the convenience. I am writing it c1. So y is equal to c1 x square plus c2. Very simple, right? Next is, so in this case, this was the case when the dependent variable was missing, y was missing. Let's see the case when x is missing. So solve the equation y times y double prime plus y1 square equal to 0. This equation is non-linear, and you will see how easily we are solving a non-linear equation when x is missing. The trick is same. We will substitute y prime by p. So y double prime is derivative of derivative of p, but we don't want to involve any x. By chain rule we can say this is dp, the derivative with respect to y, times dy over dx. Dy over dx is our p times dp over dy. Okay, let's put this in our equation. So y times, let me write it down. So we are substituting in, say, equation 1, give it number 1. So y times y double prime, which is p times dp over dy, plus y prime square equal to 0. This is a first order equation where p is dependent variable and y is independent. P is dependent function and y is independent. Let's divide by p, divide by yp to make the coefficient of dp over dy equal to 1. So we have 1 over y times p equal to 0, right? Again, this is a separable equation. So dp over dy is equal to negative p over y, negative. So we divide by p both sides and we get negative 1 over y dy. The integral is equal, right? So ln p is equal to negative ln y plus ln c1. So ln p is equal to ln of y power negative 1 plus ln c1. Here we are using the property of log, which is b times ln a is equal to ln a power b. This basically moves into the power. Okay, then we take the exponential both sides and we will get p is equal to c times c1 times y inverse c1 over y. So we got the value of p. Y prime is equal to p. So if we integrate both sides, so this p is a function of y, right? So we will integrate both sides with respect to y. Oh wait, so we have y prime is equal to p, so dy over dx is equal to p, and p is c1y. So integrate both sides with respect to y, we will get y dy equal to c1 dx. Okay. So integration of y is y square by 2, integration of c1 is c1x, and we add a constant of integration. If we multiply by 2, we will get 2 times c1, it's a new constant, I'm just writing it as c1 x, plus 2 times c2 is again a new constant, we can just say it's c2. So our y square equal to c1x plus c2 is the solution for given equation. So these are the two cases when independent variable is missing or the dependent variable is missing. So if you have a second order ODE, doesn't matter if it's linear, it's non-linear, it have constant coefficient or not, if you have a second order ODE, you can easily solve it if independent variable is missing or dependent variable is missing. If one of them is missing, you can easily solve it by substituting or introducing a new function p equal to y prime. Okay. We'll stop here today, and in the next lecture we are going to talk about higher order ODEs. Okay. So practice some more problem and take care. Bye bye.